Hi everyone, welcome to this video where I'm going to show you and highlight some of the features of JSol'Ex. So this is the software for processing your Sol'Ex videos and get some nice images of the sun disk. And I think this is my first video in English, so I'm going to go with just the basics in the beginning, show you how you can process a single video, customize some parameters. Then I'm going to go with the batch processing mode to show you how you can process multiple files at once. And finally, in the second half of this video, I'm going to dive into one of the most interesting features of this software, which is what I call the ImageMath script. And this is really a powerful mechanism to actually really tweak how you generate images, and we're going to show how you can use that typically to process Helium images. So let's go into the first and most basic processing that you can do. So just select a file, and you have these process parameters which is open, where you can select different parameters. The first one is the wavelengths that you're observing. So you have a list and you can customize the list. I'm going to show you how you can customize that later. But basically, if you select the wavelengths there, the software is going to do a couple of things. So first, it's going to add some metadata in the feeds file. And the second thing is that for some of these wavelengths, you actually have some automatic coloring which is available. So typically, if you choose H alpha, we're going to be able to colorize some of the images for you. The second one is called the pixel shifting, and this one is basically when we're going to reconstruct the image. Normally you just have this pixel shift of 0, which means that we're going to take the pixels from the detected spectral line and right in the middle of this line. But sometimes you're going to want to observe slightly up or down, or maybe, yeah, for Helium we're going to observe like many pixels off from this line, so you can customize that if you want to. The third parameter is only available when you actually observe in H alpha, so this is the Doppler shifting. Usually you don't want to tweak that parameter, but this is basically the number of pixels that we're going to take up and down this spectral line to generate a couple images. So one shifted up, the other one shifted down, and then we reconstruct these Doppler images based on these two images. The other one is the next one is also for Doppler programming. So sometimes the red and blue channels are just shifted. So if you want to switch these, you can just check this box. The next two parameters, usually you won't have to do that, but sometimes it can happen that the software will not detect properly the sun disk when reconstructing the image, or not override properly not detect properly, sorry, the tilt. So you can override what the software is going to detect to a fixed value. And this can be useful typically if you have really something that you know is a perfect circle right out of the box in your video. Maybe you just want to override that to 0 and XY ratio to 1:0, and then process your images. This can also be useful when typically you don't have, in your video, you just have a long focal length and you don't see any of the sun borders at all. In this case, you will definitely want to check these two boxes and set 0 for the tilt and set 1:0 for this XY ratio, and then basically the software is not going to try to detect an ellipse around the images because there won't be any ellipse to find. So this is really the most interesting use case for these two checkboxes. Sometimes you want to, just do some horizontal or vertical flips, so it's pretty straightforward. This one, I really do not recommend that you check this box. And this is when you have, so typically when you capture the image or your video at a cedar rate, it's going to produce a huge video. And in general, what we do is that we just rescale the image. So we detect the ellipse, we rescale the image, and the rescale is going to be done so that you have a perfect circle. And if you check this, it's going to rescale to the maximum length. So it's going to interpolate a lot, typically in the vertical axis, and so it's going to produce really huge images. So unless you have a very large amount of memory on your laptop or computer, don't check this box. This one is just going to add some sharpening of your images when you process that. So you may or may not want to do that depending on what if you really have some blurry images, maybe sharpening is interesting. Usually I keep that unchecked, but try this if you want to. So yeah, let's just go with that right now. So I selected this file, and now I have two main buttons that I can use. The first one is the one that I use the most when I'm actually doing some initial setup, and it's the basic image processing. So it's going to show you the scan that you have out of the box, and then do some geometric correction, and you can see if the image is good, basically. So if you just look at this one, it is almost circular, and this one has been geometric corrected, so it's a perfect circle. So that's why you have this XY ratio here to 102. But typically, in the beginning, you do sessions, and you will have to set up the focus, you will have to set up the tilt, etc., etc. So the quick mode is perfect for that because you're just going to generate some images. Then once you have your setup ready, you probably want to go into the full process mode. When you do that and you click that, it's going to do the same, but then it's going to generate all the additional images that JSol'Ex is able to produce. So in this case, let's start with the beginning. You have a colorized image. We have this stretched image for which you can adjust the contrast if you want to with these buttons. You can zoom in and out by moving this or by doing some control clicking, and then with the mouse wheel you can basically zoom into the image. I'm producing this also this negative image, which often shows some nice details that you cannot see just with the regular one. Like here we can see really I think the 3D effect is quite impressive on some of the images. Then we produce this famous Doppler image, the virtual eclipse, so some kind of coronagraph. And the last one is a combination of the coronagraph with the colorized image. So you can see that the contrast and the luminosity is not quite the same because we try to actually improve the contrast of everything which is close to the limb with the image in the center. So it's a bit of a combination of two different images, but it has some nice nice outcomes. So this is the basic of processing. I can show you some more difficult images because I've been given with lots of videos to use which didn't pass well. But let's take, for example, this one, which was an H alpha again video. Let's do some full processing and see what it produces. So this one is more than it's almost a couple gigabytes, but you will see what it produces out of the box. So if we go to the reconstruction one, you see that it's actually really an oval. It has some some defects. The focus is not quite nice. Not so nice. But still, we are able to correct that and generate everything, all these images. And yeah, the Doppler image doesn't make quite sense in this case because the tilt is too high, but you get it. right? So now let's try with a different wavelengths. So I'm going to go to calcium, select, say, this one. I'm going to select calcium K, and you're going to see that if I do the full process mode, then what I'm going to get is a different image, and this time it is colorized in this violet, right? And again, the initial image wasn't perfect, like you can see the oval right now. So this is interesting, and now I'm going to show you some more parameters that I can tweak. So of course I can do, instead of going to open file, I can just go to recent files and just reopen. But now I'm going to skip the second one and go to the third tab that you have there, and there you can select more options. So the first one, which is always checked, is basically assume mono images, and that's a performance optimization. So in most cases, what you will get is a mono video. All in black and white and gray levels. If it's not the case and what you have is actually color, you can uncheck that and the software should be able to process that. But in general, you just want to keep that checked because you're going to have mono images, and then the software is going to process your images faster because it doesn't have to do some demosaic that it would have to do otherwise. This checkbox is basically, by default it is checked actually. If I do to reset by default, you can see that it is checked. What I have is that by default it's going to save all the images. Usually I uncheck that because in the beginning, when I'm going to do this initial setup and do with the quick mode, I basically don't want to fill my disk with images that I'm not going to use. So I uncheck that, and what means that if I want to keep an image with that, which I see, I will have to click this save button for all the images that I want to keep on my disk. If I check that box, then all the images that it's going to generate are going to be saved, right? Then you can select the different kind of images that you want to have. So I don't use the feeds file right now, so I'm just going to uncheck that. I'm going to use JPEG files because it's just for posting on forums and whatnot, so I don't need to have these high high quality images. So let's just go with JPEG, and I'm going to check this guy, which is generate debug images, and we're going to see what it's going to provide as a bonus. Then the two other parameters that you have there are related to correction of the transversalium. So you see these dark lines that you have in the initial image that we're able to correct. And you have two parameters to tweak these. So one is the correction width, and the other one is the number of passes of the algorithm. So in general, you want to keep the number of passes quite low. You can increase this parameter or decrease it. This corresponds to the width of not the defects, but the width that the algorithm is considering when it's computing some statistics of the image. So typically when you have a dark line, its mean value is below the average of all the other lines in the same band, and that's what we use to correct everything. So I'm resetting the default there, and we're going to use that to process. So check this, and let's go with the full process again, and we're going to see that now when I check this debug thing, you can see that the reconstruction actually happened live. So you can see that happening live, and then we have this average image which is generating it, and it shows you where the spectral line is detected. So it can be useful. Sometimes maybe you will see that it's off and it doesn't match what you expected. Then you can see the edge detection being applied. So if you zoom in, you can see all those red dots, and that's where the algorithm has detected the sun edges. These other image that you have there is used for the geometry correction. It shows you the detected ellipse, and the two red squares, the larger red squares that you have there, actually are used to compute the tilt angle. So here we see that in this video we had something which was tilted with more than 1 degree, and more than, yeah, the tilt angle, sorry, is here more than 1 degree, and the detected XY ratio was, yeah, not so close to 1, but it was corrected, and that's where you can see that. So if you have some videos which don't work well and don't produce good images, it is always interesting to go into this checkbox and check it so that you can see what it actually generates and what it detects. Then we're going to go with the basics of what JSol'Ex does in terms of saving. So by default, the default saving of files is so that I am generating basically a subdirectory corresponding to the name of the ser file. So I know that int, for example, is putting all the files into the same directory, which I quite didn't like because I like to have everything in a separate folder. So the default in JSol'Ex is actually to create a separate folder for each video, and then I have a subfolder for each kind of video. So typically the processed one, like the negative image, the mixed image, the Doppler image, are in a subdirectory called processed, while the reconstructed image are in the raw directory, etc., etc. So you can actually tweak that. And if you're not happy with the defaults, you can actually change how the software is going to generate that. So you can go there. So typically I have created a new pattern there that I used for not just batch. Actually, I use that for many of my development process in order just not to fill my disk with just a huge number of directories. I'm just creating this batch directory and then adding the current date time as a subdirectory, and then the sequence number is the number of the image in the batch, and then the label is just typically disk or the mixed image, average image, etc., etc. So you can actually tweak everything if you want to, if you're not happy with the defaults. So I'm going to stick with the batch one for now because this is a process I like, and not check this, and go to full process again to show you how it does that. And now if I want to see that and save that file, there's nothing that I don't have the file on my directory. But what I can do is that, okay, I say I want to keep this one, so I'm going to save this file, and now I right click on the image, and it's going to open my Explorer with these files in, so I can see all these files. So you can see that I had already processed some images today because I'm using the date, not just the date time, but my image is in that directory. So let's get rid of all these files and do it, say, for these where is colorized one. So I'm going to adjust the contrast a bit, so then I'm happy with that. I'm going to save the image, right click, show it there, and I have the colorized image and only this one saved. Right. So this is the difference between having this flag autosave, and everything would be saved out of the box, and unchecking when you have to select everything. So the second tab, skip that for now because it doesn't really matter unless you want to have some metadata in your feeds file. So if you want to have some metadata in the feeds file, you have to fill in all these. The only field which is actually filled by default is the date, which is fetched from your SIR file, and the second one is this one, which is set by default to JSol'Ex, so the instrument one. So I'm not filling all those fields. You have to do it, and one of the reasons is that depending on the software that you use, the observer name can be different. There's no contact email, or the telescope for telescope sometimes is going to say JSol'Ex for telescope, or I also saw in some cases that the telescope was set to the camera name, so there's no standard actually that I can use to fill that automatically, so I don't do that. So you have to do that manually if you want to have these metadata. But for just if you want to say generate PNG or JPEG, you don't have to care about these at all, right? Okay, so now I'm going to show you another interesting feature, which is to select precisely all the images that you want to generate. So instead of doing with the quick mode, where it was actually generating just a couple images, plus the debug images there, let's uncheck that, or to do with the full process, you can actually click on there and select which images that you want. So say that I'm only interested in this mixed image and that's it. Then I can check this, click OK, and then it's only going to generate that image and nothing else. So again, just shortcuts so you can precisely select what you want. Now I'm going to demonstrate the batch mode, which is interesting because it behaves slightly differently. So I'm going to go into this directory where I have these many files, which are quite different files with different tildes and whatnot. So I'm going to select all these, and I want to process them all the same, and they are all H-alpha videos. So now I'm going to go there, and the difference now in the batch mode is that you cannot select these automatically save images because it's not going to display the images in the directly in as images in the interface because there are going to be too many images generated. So it's going to store them on disk always. But the rest you can configure, so you can select what format you want to export to. So I'm going to use JPEG. I could choose to generate some debug images, but I'm not going to do that. What I'm going to do instead is go to the custom process and say that for my batch, what I'm going to do now is to generate this mixed image, but I also want to see the uncorrected image, like what is actually out of this video, and the corrected one, which is after geometric correction. So we're going to check this, and now when I go with OK, you can see that interface is different. It's showing this batch process with the list of all the images, and as the process is running, we have all these images available. So I can click there, and now we can see all these images coming. So typically when I go here and I look at this image 8 there, this is what we have out of the process, like this is the image raw and transformed, and then we should have the 8 image, so 8 mix, this one, which is the corrected one. So you can see that even if the disk was truncated, it works perfectly. We also have the Sclahi image there with in monochrome, but it worked. And sometimes we have really images like which are in different directions or very wide. It doesn't matter. The software just can process them directly. So all this were processed, and this is actually this batch mode can be quite useful. In this case, I generated this mixed image, but probably what you want is to generate a batch with all those geometric corrected images, and then take these images, bring them to AutoStack it or your favorite stacking process and just generate a stacked image instead. So you can do that. And that's the interest of actually configuring here the output directory to the batch mode with a single directory and put all those files into a single directory in this case, so that you have all your files of the single batch in a single directory. So yeah, that's basically what you can do with the batch mode. Alright, so now I'm going to open this tools menu because it's also something interesting to show. So you can directly, instead of going through and having to open these files, you can go through the menu and you have the file name pattern editor directly available if you want to change your patterns. And the second one is this spectral ray editor. So when I told you in the beginning that you can actually select the wavelengths, this is where you could add some custom wavelengths if you missed them in the software. And you can set the wavelengths, which is going to be stored again in the fits file, but then you can change the color curves if you want to. So there's a color curve for H alpha, there is none for H beta because I haven't done that, but if you want to, you can say take the color curve and then you're going to do this and whatnot, modify all these color curves so you can see the preview, and when you're happy you click on OK and that's good, right? Or you could add some custom values, like say that you want to add a, I don't know, yeah, yeah, so the iron wavelengths, you can add the wavelengths, etc., etc. So I'm not going to save because I modified the color and I want to do that, but once you're happy, just want to click OK, and then it's going to be saved on disk, and you can reuse that, and then they would be available in the processing when you click on these recent files and these three buttons. This is exactly the same interface, so they would appear in this list there. All right. And for the last one, the last tool that you have there, the Spectrum debugger, I'm going to show you actually live in action, and that's where we start with the second part of this video, and I'm going to explain you with this tool which is called ImageMath, right? So to show you what you can do with that, I'm going to do with Helium processing. So when we do Helium processing, typically what you have to do with Inti and actually you have to do some more work than what you're going to have to do with this software because you have to take several videos and one of them is going to be used to compute the shift between a dark line in the spectrum and the actual helium line, which is light line in the spectrum that is not visible to the human eye and not to the software either. So you have to explain to the software where this helium line is, and this is where we're going to use the spectrum debugger there. So I'm going to open this file that I have for helium processing, and we're going to use the video which is on the Inti website to demonstrate how to do that. So when you go to this frame debugger, spectrum line debugger, what you have is the average image opened, and this is the line that the software has detected. And it's a dark line, but it is not the helium line. So I can switch to frames, and when I move the button there, actually move in the video, and depending on where I am, like you can see that the detected line actually moves. So obviously when the software doesn't see anything, the line is totally random. So that's not what we want to do there. So what we're going to do instead is go to this average and then click on lock the polynomial. And basically we say, okay, this line that we detected, it's fine. And now we're going to compute an offset from this line by selecting a different frame. So I'm going to move now to the edge of the sun. So right in the beginning, so close to the edge, close to the limb, right? Something like that. I'm going to increase the contrast, and now we can see this line coming. And this is the Helium line that we're interested in. So now what I can do is so I'm pressing Control on my keyboard, and then I'm going to click several times on this line. So I'm putting some red crosses, and that's enough, right? So now I have all these red crosses, but if I go there, you can see that it shows you average shift from points. So it tells you what is the average distance between this line and the crosses that we put. So this is the distance, the pixel shift between the line that is detected, the dark line that is detected by JSol'Ex, and the line that we actually care about, which is this Helium line. So if we run that, it's going to be minus 60. Okay. So minus 60 is what we're interested in, and then we know that when we're going to do some Helium processing, what we're going to have to do also is to remove the continuum, so subtract the continuum value. So we also need to figure out where the continuum is going to be. So I'm moving, reducing the luminosity, and let's say that we take this here. So we have a shift which moves, so we can see that the shift is the cursor there. So we can see that the shift is between, say, 35 and 40. So 35, 40 would be a good continuum to choose. We're going to try that, right? But this is the initial step that we have to perform in order to process the Helium line. So now I'm going to open this file into JSol'Ex. So again, I'm going to go to Helium, select my file, but instead of going with H alpha, I'm going to select this Helium color, and actually this is not for coloring, this is just to get this metadata into the fits file. And I'm going to click on custom process. But now I'm going to say I am not interested in any of the images that you're going to generate. So I'm unchecking everything. And instead, I'm going to go into the special mode, which is ImageMath, and open that. So there we're going to write a script. And I'm going to show you what the script is, but if you don't know and if you want to have docs, you can click on that button and it's going to bring you to the documentation directly online, where everything that I'm going to describe is actually documented here, right? So we come back there, and there we can write some scripts. So the script that I'm going to use is image and use minus 60. And this means pick the image which is the offset, like the shift of minus 60. So 60 pixels up the detected line. And then we're going to subtract the continuum. So let's say that we subtract it with the image at offset minus 35. I'm going to save that into a demo file, replace that. Oops, I made a mistake. And that's because, I'm on the development version. I was modifying, but it won't behave like that on yours. Anyway, so we can run that, click on OK, and now we have our image which is generated there. So you can see it's quite dark, but you can adjust the contrast. Should be able to see something, yeah. So this is better if I go really, really low on the cursors there. But you can see that it looks quite like what we would expect from a Helium image, except that we can do much better. So now what we are going to do is that we're going to use this script language to improve that a bit. So typically we were not quite sure if the continuum that we wanted to use was the right one. So instead of minus 34, maybe I want to try minus 40. And I'm going to run again, and we will be able to compare the images. So I'm going to stretch again. So I was at 34, so maybe let's try to get to 34, 32, 34, yeah. So 34. So now we can compare the two, and actually you can see that the first one was actually quite, yeah, it was better. So this parameter is probably better than the initial one that we had. But maybe if we kind of lazy, what we want to do is actually do something a bit better. So instead of just using a single image, I'm going to use the maximum of a range which goes from minus 40 to minus 35. So when I'm going to do that, the difference is not going to be made on two images. We're first going to compute images with different shifts, ranging from minus 34 to minus 40. And then we're going to take the maximum of all those images. So pixel per pixel, it's going to compare the images, and it's going to take the maximum value of all these. And for the continuum, it quite of makes sense to take the maximum. We could use the average, and actually we will be able to compare, but let's see what it does if we do that. So we run again, and we're going to adjust the contrast again, and we can compare 34, 34. So let's compare with the initial one. You can see that there's a difference in the details, especially now. I think we can reduce the contrast a bit, yeah. But we have this image which is a bit better. We could actually remove this and re-execute, and it's going to be faster because now it has all these shifts in memory, so it doesn't have to compute everything. But again, we can do better. So because if we look at this contrasted image, and this especially, yeah, when we raise the levels, we have all those lines which are not quite nice, right? So maybe what we want to do instead is to, not instead, what we want to do is to perform some correction of this. And let's do that. So I'm going to start going into a bit better, into a bit more details into what you can do with ImageScript. And there I'm defining a section, which is the output section. And in the output section, I'm declaring what image I'm interested in the end of the processing. So let's call it final, like the final image. So I'm saying final equals, and then the formula that I want to use. So if I run this again, the name here, which is generated, is what we have there. I can close all the previous images if I don't care. So if I run that again, now it's only generating the last image. And again, I can adjust the contrast to see what it does, but it's exactly the same except that now I have given it a name. But now I'm going to move this into a temporary image. So let's call that the raw image. So now, this is a bit dumb what I'm doing, but I have this raw image which is generated here, and I'm just saying the final image equals the raw image. And I'm running again, and you can see that it does exactly the same because this is just a simple assignment. But instead of doing that, now I'm going to try to fix these lines. So there's a built-in function which is called fix banding, and what it does is that it takes the image as a parameter, and then it takes the banding width that we've seen in the beginning of the video, and then the number of passes. So let's say that I'm doing a width of 25 with 3 passes, and run again. Now we can look at the generated image, and we should have less lines, but still we have some lines. So maybe let's do a bit more aggressive, like 10 corrections instead of just one, of just 3, and adjust the contrast again. Let's do this. Oh, it was better there. So these lines are slowly disappearing. So you can adjust that, and maybe you want to adjust the banding width, the number of iterations, and the more you add there, the wider and the larger the number of iterations you're going to do, the smoother the image is going to be, but at the same time you're going to lose some signal. So depends on what your objective is in the end. But if you just want to have some nice image to display in the forums, maybe being some aggressive, especially in the Helium line, is something that you want to do. So there, yeah, we have something which is okay, right? But we can do, yeah, still better than that, because I was just continuously continuously just adjusting the contrast, which is not quite nice. So now, instead of using the raw image, I'm going to add a new image there, like say contrast adjust, and then we're going to call the Clahi correction, and we're going to do that on the raw image, and it takes one parameter, which is the clipping factor. And now, instead of using the raw image, I'm going to use this contrast adjusted image and run again. And now we can see that it's better than in the previous case. So let's compare by actually, oh, I can do that. So instead of just generating one output, I'm going to compare the two. So without, and say that we have so this raw image, so the fixed banding of the raw image, and we're going to use the same parameters a couple times. So without the contrast adjustment and with the contrast adjustment, and we're going to be able to compare the two images. So you can see that the contrast is a bit better on this one now. But still, we would like to play on this factor, but now, instead of having to go very low and being very aggressive in this stretching, we can just go a bit smoother. So I'm going to remove this one, and I'm going to do a second level contrast adjustment, which exactly corresponds to what we were doing in these adjustment sliders. So the function that you have to call in this case is called what's the name again? I have a memory issue. Adjust contrast. I think it's just that, adjust contrast. And then it takes the two parameters, which are the low value and the high value. So we're going to use 0 as the low value, and the high value is between 0 and 155. But in this case, let's use, say, 200. So now run again, and we should have something which is closer to what we expect from the actual Helium image. It starts looking good, right? So there's obviously much more than we can do, but it starts looking okay. Now, something bothers me. Well, a couple things bothers me on this image. So one of the problems is that the image is not square. So maybe what we want to do is to square this image. So let's do that, and let's call images, create an image called square and called Autocrop on this contrast adjusted image. So I'm calling it called squared, and now the squared image is there. I should call it square, because squared could it make it like it's image multiplied by itself, which is not the case. So let's call it square. Run again. And now we have this image which is automatically cropped. But something is quite wrong with this image, and I don't know if you can see that well, but it seems that there's a shadow there, like a circle, or something is wrong. And this is because we made a mistake. The fixed banding thing must work before you actually do the autocrop. So it means that now we cannot do the fixed banding before. We cannot do that after. We have to do that before. But it is not a problem there. Well, we can just do that, right? So I'm going to create, well, actually we can do that now, like fixed. Let's call them an image fixed and do fix banding. And we're going to fix the banding of the raw image with these 50 and 20 parameters. And then the contrast adjustment is going to be on a fixed image, and the square is going to be okay. But now we can remove the banding fix correction from there. Let's call it the final image is the square, and we run. And boom, what we have is the image, and now we don't have this slight shadow there. The image correction is quite nice, but we can still improve the image because there's this background that I quite don't like. And if we zoom into the image, we see actually that we have some details there, which would be nice to see somehow. So let's try to remove this background. And that's what I'm going to do now. Remove background of this. And again, we're going to see that we have an issue. So it computes the square, and we have exactly the same problem as with the fixed banding, but it is obvious in this case. And again, this is because the removal of background has to be done before doing autocrop. So the background removal, I'm going to do that here, or we can do that before, like it actually makes more sense to say that the fixed image is also the one with the removed background. And the final image is going to be a square now. Run again. There we go. Background is removed. And the problem is that, well, it seems to have removed some of our details, but actually they are here. It's just that the contrast is not quite nice. Like if we push the limits, we can see something happening there. The data is here. Like if we really shift there, we can see that the data is still here. So how can we make that more visible? Well, you have different options. One which works perfectly well there is actually to do some colorization. You could also do an arc scene transform that I'm not going to show in this video because you can go on the documentation and see what it takes as a parameter. But now I'm just going to show you some automatic colorization. So I'm going to create a new output image, which is going to be called colorized. And to do that, I'm going to call colorize the square image, and then it uses one parameter, which is the name of a colorization profile. And this is what you have there. It is called Helium v3. So copy and paste, just do that. And now if I run, what we're going to have is our image, which is colorized. And if we zoom in, the data that we have there is actually more visible than what it was just in monochrome. So I don't know why. It's probably because the naked eye has better sensitivity there with the green. So yeah. So just now, what we have is a script which processed this video automatically, and you can save the script. So we're going to do that. You can save the script. Go into the test files. Let's do demo helium. Replace that. And then you can share that with other people. But I would recommend if you, before sharing, to do some what we call in development, we call refactoring. It is basically extracting some parameters there that we have, such as that people can actually tweak them more easily and know more easily what they want to, they can tweak in the script. So actually when we're going to process some Helium video, what you care most about is the shift, so the -60, the continuum, so these two values, and we're going to do that for now. So I'm going to create a new section called temp, and this is just a label that I give to this section, and another one where I'm going to call that params. And now this 60, I'm going to remove that and add a parameter, which I'm going to call Helium shift, and assign it -60. And now I can replace this into my expression, and I can do the same for this continuum low and high value. Continuum low, and let's do the same with continuum high and use -35, and I can use these parameters there. Boom, there you go. And now if you share this script, actually you can tell people, well, actually just update these three parameters to whatever you have. Ideally, you would also create some parameters for all these other parameters that we use there, like the stretching, the number of bending corrections, etc., etc. So I'm going to share actually a script at the end of this video, which does exactly that, but this is how you can actually perform all these modifications. And we're going to see that in action. So now I'm saving the file again, and let's say that I need to process a new Helium file. So I have another file that I want to process, and this was shared by Sylvain Weiler with me. So it's a 1.3 gigabyte video, and you can see that the line is quite different, but the process is going to be exactly the same as before. So I'm locking the polynomial, I'm going to do the frames, go to the edge of the sun, there we go, increase the contrast, I'm going to go right where we can clearly see this, control click on this line, just a few points is enough. Read this value, -85 is the shift that we're interested in, and then the second parameter that we want is this continuum, so I'm moving back to say the average image, but let's increase the contrast. And you can see that in his video, actually the continuum is harder to find, but we can probably choose something between 40 and say, yeah, just for this video, let's say 48. 40, 48 and -85. So now I'm going to process this video. I'm going to go into the custom process, open ImageMath, and I'm going to update -85. We said 40, 45, if I remember correctly. Doesn't really matter. Just run OK. I didn't save. It told me I should have saved. So we're going to see that it's not going to produce a nice image because the shift is not right. But we're going to be able to, yeah. It's not a Helium image because I didn't save the script. But no problem, I can actually change everything there. So I can go there, 45, run again, and let's see what it produces. It's going to take a few seconds because it has to recompute the missing shifts. And again, the file is much larger than the initial one, but there we go. So just in a few clicks now we have a script which we can share with other people so that they can process their own Helium image. So now if I go to this video again, let's say this one, which is faster to process, go to custom process, and a page open. So I'm going to remove this script. I don't want it to apply. I want to use the script which has more parameters. I'm going to share with you. So this is the script that we're going to use. It has more parameters. It has the Helium shift. It has the continuum, low and high value. You can actually tweak slightly the subtraction between the Helium ray and the continuum. So you can apply a factor. By default, it is 1, but maybe you want to apply less or more. Stretching factor of the image for brightness, depending width, number of corrections, the clarity limit, etc., etc. And then we have all the internal mechanisms to generate some intermediate images, and the output images that we want. We have a couple images. One is the monochrome one, and the second one is the colorized one. So now we're going to run that, and we're going to have our image generated in just a few seconds. So really, really fast to get something. There we go. How nice is that? Cool. So last thing, so just to show you what you can do with these scripts, again, let's take the initial image, reset the shift to default so that is 0 and not -60, and let's go with quick mode. Now I have this image, and I'm going to remove everything there, but I can do image 0, and it's going to produce the exact same image. But now let's say that I want the average between not in this line just in the middle, but 1 pixel off, and see if there's a difference. We can actually check that very easily, and you can see that it's actually a bit better, right, to do that. Like, instead of taking right in the middle of the line, taking 1 pixel off the line gives a slightly better image. So you can actually tweak everything, and if you want to, you could even do some subtractions, some multiplications, division, whatever you like. So if you're interested in that, just don't hesitate to look into this and process images, share your scripts. I think it is quite a powerful tool to actually be able to deal with all the how we call that, the signal that we have in these images, because there's a lot of that. But when we go with the automatic mode, like if I reprocess this and go with the full process, I don't have access to all these parameters. You have access if you actually do image script. You have access to everything, and you can tweak everything. So the image scripts won't let you generate the Doppler image yet. I'm going to work on that. Nor the Eclipse. So this is mostly for visual and showing on the forums and things like that. But for everything else, like if you want to do some science, you can actually do that directly. So let's say that I actually want to generate this negative image there on this average. I can just do that, like negative. So it's called negate. No, negative. So it's cool because it's in red when I make a typo. Oh, so let's go to the docs. What's the name of the negative image? Oh, it's called invert. Of course, it's invert. So let's go with invert. There you go. It's not red anymore. Run. And now we have that. And let's see that it's actually less contrasted because this is raw. Like we have inverted the raw image, like the corrected one, so it's geometry corrected, but it doesn't have the contrast adjusted. So maybe what you want to do is apply the clarity transformation on these and pass it some parameters like 1, 1, and execute again. And then there you go. Oh, it's a bit hard, so maybe you want to tweak that and say compare with 0.5. What does it do? Let's not close the previous image so that we can compare. And it's actually a bit better. So you can tweak these parameters. If I put 1.5, again, you would compare. And you can see that the higher you put the value, the more contrast it's going to bring, but also the less contrast, the more signal you're going to use, to lose. Sorry. Yeah, so that's basically all I wanted to show you today. It's a lot to digest, so I hope that it was insightful, brings you all the information you have to know about this software. I'm spending a lot of time developing it, so don't hesitate to create some bug reports on GitHub. Even if you want to send me some videos which don't work well or not processed correctly, don't hesitate to do that. I'm really happy to work on this and fix. If you have some ideas or some functions that you want to be implemented, things like that, don't hesitate. Yeah, thanks a lot for listening, watching, and talk to you later. Bye.